Hello guys, so welcome to our next lesson. This is going to be talking about searching and sorting algorithms. So these are two kind of big problems in computer science and big important things. So we're going to talk about searching first. So the idea of searching is to look for an item in a list and then return a Boolean for whether or not you found that item. So suppose you have some list, and this list could be either an array or an array list, some kind of way of storing data. And let's say we just have a list of names. I don't know. Allie, James, Madeline, Carrie, Frank, Jason. Okay, it doesn't matter. Just a list of names. I just pick some ones. So what we're going to do is we're going to talk about different ways to approach searching. And the first one is what's called sequential search. And this is something you've done a million times. And basically the way to do sequential search is just loop through the list and then check each element. And if that element is the one you want, return true. And then if you got through the entire list without finding the element, then in that case, you will return false. So let's talk about what this will look like. So here's your list, and I'm going to kind of highlight through with my mouse. So let's say I'm looking at this list, and I'm looking for Carrie. So I'm just going to go through, in a sense, and just have a for loop and say, okay, are you Carrie? No. Are you Carrie? No. Are you Carrie? No. Are you Carrie? Yes. So I return true, Carrie's found. And that's what the method does. I don't even need to look through the rest of the list. Now let's say I look for someone who's not on the list, like my son Wesley. So are you Wesley? No. 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 Are you? Okay, so there. So then if I got through the whole list, then I just say, hey, Wesley is not found. I return false. So, I mean, this is something like you have done this a lot this year. So sequential search as a way of searching through a list is something that looks familiar. Okay, but the next thing I want to talk about is something you haven't done. And this is called binary search. In binary search, the caveat here is binary search can only be used if your list is already in order. But if the list is in order, this is way faster than sequential search. Okay, so let's take a look. So let's suppose we have this list, and I'm just going to have a list of numbers. So I'll just pick, I don't know, like 2, 4, 5, 7, 8, 9, 10, and let's say 13. Okay, so now what I'm going to do is I'm going to say, all right, instead of just looking at every individual element, what I'm going to do is I'm going to look at the middle element. So the idea is to look at the middle element. Okay, so let's say I'm looking for, I don't know, a 4. So I'm going to look at the middle element. I mean, there are 8 units, there are 8 elements in this. So you could say the middle element is either 7 or 8. You can make an argument for either one. And coding-wise, you probably round down, but it doesn't matter. So you're going to look at 7. And you're going to say, okay, is our number, our target, so our target is like the number we're looking for. So in this case, 4. Is 4 bigger or smaller than 7? Well, 4 is smaller than 7, right? That's obvious. So if we know that 4 is smaller than 7, because we know this list is already in order, is it possible that that number could be past 7 on the right of it? And the answer is no. So what we're going to do is we're just going to see, well, first off, see if the target is the middle element. And then if so, obviously you return true. And then if not, then basically what you're doing, I don't need it. Okay. If not, we're going to see, is the target bigger or smaller than the middle element? And then basically what I'll do after that is then I'll just cut the list in half. Binary by means 2, so you cut the list into 2 parts. And then you're going to kind of do this again on that half. And when you're doing this again, you could do this in terms of a while loop, or you could do it with recursion. So I'm going to say, okay, the middle element is a 7. 4 is smaller than a 7. So 4 is smaller than 7. So then in this case, my new list for the target 4 would just be 2, 4, 5. If 4 is smaller than 7 and the list is in order, there's no way it could be bigger. So again, the list has to be in order for binary search to work. Okay, so now we do again. So again, we look at the middle element, which is 4. Okay, 4 equals 4, of course, so in that case, you would return true. Great. Now, let's look at the next case. So let's do this again. And let's say we have a different target. So let's say again we have this list, and let's say we have a target of, I don't know, 11. All right, so when you look at this, you again compare the middle element here. So 11 is bigger than 7. So what I do is I kind of just cross off everything that's before it. I'm kind of chopping it off and saying, okay, let's look at the part of the array that comes after that 7. So that's 8, 9, 10, 11. Or sorry, 8, 9, 10, 13. So again, I'll look at the middle element. So I get to here. And you could look at the 9 or the 10. Again, you just round down if it's an even number length. Okay, oops. And again, like, okay, I know that 7 is smaller than 9. So again, I can look at this and say, all right, or sorry, I'm looking for 11. I'm stupid. Okay, 11 is bigger than 9. So I'm going to cross off the 9 and then everything that comes before it. Okay, so now we get down to the list of 10 and 13. So what this means now, I look at the bigger element. Okay, so then the middle one's 10, so we'll cross that off, and then we just get to 13. And then we only had one element in this case, and that's not it. So now we are down, ooh, I did not mean to still be crossed off. So at this point, we are down to 0 elements. So what that means, if we're down to 0 elements, that means that we didn't find it and return false. Okay, so this is binary search, and this is certainly more complicated. Just the idea of looking at the middle element. Okay, are we bigger or smaller? Look at the middle element right here. Are we bigger or smaller? We're bigger. Or look at the middle element. Are we bigger or smaller? Bigger, and so forth. I know this is more complicated than looping through, but think about the advantages of this. Like, all you do is look at the middle element and cut the list in half. So if your list, let's say, has, I don't know, 1,000 entries, if you just cut that in half, it goes down to 500, and then 250, and then 125, and then 63, and then 32, and then 16, and then 8, and then 4, and then 2, and then 1. So you actually only need to compare, let's see, 1 comparison, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You only need to compare 11 entries instead of 1,000. So that's the beauty of binary search, is if your list is already in order, you can just look at that middle element and say, am I bigger than that or smaller than that? And just chop the array in half. Say, okay, I'm bigger than the middle element. I'm just going to eliminate everything from the middle element on before and continue looking. Eliminate everything on before and continue looking. Okay, so that's the beauty of binary search. So those are different ways to look through a list. Now, you might have wondered, hey, binary search, the list has to be in order. How do I put the list in order? And that will be the next video.